Our next topic that we're going to be going over is on particle motion. And this topic has a lot of formulas that are just necessary to know. Here are some of the formulas and concepts. So position is often given to us as S of t, x of t if it's horizontal, y of t if it's vertical. S of t can be either one. Those are often seen. Velocity is the derivative of position. Velocity is derivative of position. Average velocity is change in position over change in time. Average velocity. That would be the average S prime. All right. Particle is moving up when v is positive, when velocity is positive, moving to the left when v is negative. That's if you're going horizontally. If you're going vertically, it's going up or down. Standing still when velocity is 0. Changes direction. The particle changes direction when velocity changes signs. To do this without a calculator, we will need to set velocity equal to 0, often factor, see where velocity is 0, and then sign chart v. With a calculator, though, we can just graph the velocity function and see where it is above or below the x-axis. All right, acceleration. Acceleration is the derivative of velocity, which makes it the second derivative of position. Average acceleration is change in velocity over change in time. Your units would be like meters per second, which makes it like meters per second squared. Speed is the absolute value of velocity. Note that speed is not just velocity, it's the absolute value of velocity, so speed cannot be negative. Speed is increasing, which means the particle is speeding up when acceleration and velocity have the same signs, decreasing or slowing down when acceleration and velocity have different signs. Displacement is just change in position. Change in position can be negative. If we end to the left of where we began or down from where we began, displacement will be negative. To find this with a calculator, we can using the fundamental theorem of calculus, we can just integrate velocity. For total distance traveled, we integrate the absolute value of velocity, because for total distance traveled, it doesn't matter if we are going to the left or down. We want to include those. Okay, to find the position of the particle at any time, you take your initial position and you add your change in position. Initial plus change. It makes sense. That would give us our ending. You know where you're starting and how much you changed, you're where you ended. Fundamental theorem of calculus. All right, let's take a look at a couple of examples. Starting out with the problem from 2013. This one was with a calculator, so I'm grabbing my calculator here. A particle moves along a straight line. For time between 0 and 5, the velocity is given by this equation. And the position of the particle is given by s. It is known that s of 0 is 10. They are giving us an initial position. Okay, so I'm going to always put velocity in for my y1. So I'm putting that in for y1. Let's all do that. Let's see. Make sure we get that in correctly, of course. I'm going to be typing it in almost exactly as I see it. putting x in place of the t's. So I take a quick look, make sure I got all of those values right. Looks good to me. Alrighty, part A. Find all values of time between 2 and 4 for which the speed is 2. Well, speed is the absolute value of velocity. Oops, it's not a vector. Speed is the absolute value of velocity, and we want to know when is that 2. And we have a calculator to help us. So when is speed 2? Well, speed is not my y1. That's velocity. Speed is the absolute value of that. So I am going to go write a y2 and make y2 the absolute value of my y1. That way, n for y2 is speed. I want to know when is that 2, so I'm going to make y3 equal to 2. Come up, turn off that graph of y1 because I don't want to see it. And I'm going to graph this between 2 and 4 for x. So 2 and 4. For my ymin and ymax, I need to make sure that it includes 2. And 2 is between -4 and 4, so I think I'll just leave it like that. So there's speed, and there's 2. Obviously, we have 2 times where the speed is 2. Let's go find those. Second calc 5, enter, enter, enter. You know you're done when you see the word intersection. So the first time is 3.1276. You give at least 3 values after the decimal point. And the other one is 3.4734. 2 times at which the speed is 2. This was worth 2 points. 1 point was for considers the absolute value of velocity is equal to 2, and 1 point for your answer. Let's go on to part B. Write an expression involving an integral that gives the position of s at any time, t. Use this expression to find the position of the particle at time 5. Well, the position at any time is our initial position plus the change in position. Change in position is going to go from 0 to whatever time we need of velocity. If you don't like having t's back here, change them to x's or some other letter. Okay? But this works well for me. We should put in 10 for s of 0. Because this is not a safe stop spot. The integral is fine because they told us it would involve an integral, but this is not a safe stop spot, so we need to give the value for that. And now we're going to use that expression to find s at 5. And we'll go to use our calculator for that, of course, and get where it's not a glare. Okay, 10 plus integral 0 to 5 of our y1. So negative 9.207. At least 3 values after the decimal point. This was worth 2 points, 1 point for our expression for s of t, 1 point for our answer to s of 5. Part C. Find all times between 0 and 5 at which the particle changes direction. Well, the particle changes direction when v changes sign. That's going to be our justification. And if you want to write that first, write it first, and then it's done. Your justification would be done. Okay? So the particle changes direction at t equals, okay, let's go see when does v change signs. So I'm going to go back to my calculator. I don't need the speed, but I do need v. So I'm going to change that to where I can see y1, and then I'm going to put 0 in for y3, because that's going to be the times that I need. I need to see when does v change signs. When does v cross the x-axis? And this time we're going from 0 to 5. So 0 to 5. And my negative 4 to 4 still has 0 inside, so I'm just going to leave it like that. So there's v. And it only changed signs twice. Here it went from negative to positive. Here it went from positive to negative. So we're going to find those two times. Second calc, 5. Enter, looks like about a half. 0.5360. And we'll go get the other one. Second calc 5, enter, that looks like it's about 3.5. 3.3177. Okay, so we need to say why. What did we do? Since v changes sign there. Okay. They awarded us 3 points total. I was a little bit surprised. 3 points. 1 point for considers v of t is equal to 0. Did we do that? Yes, we did, because v changes signs. That's when v is 0. So yes, we still did that. 2 points for the answers with justification. So 3 points for that. I think more recently they have only been giving 2 points for that. I actually think they've been giving 3 points for the position and only 2 points for a question like this. But that's what they did this year, back in 2013. Okay, part D. Is the speed increasing or decreasing at time 4? Is the speed increasing or decreasing at time 4? We need to give a reason for our answer. I can think of a couple of different ways to do this. Okay. The first way is probably the way that I think you guys would answer it. So I'm going to do it that way first. Okay. So speed is increasing or decreasing. Speed is increasing if acceleration and velocity have the same sign. Speed is decreasing if acceleration and velocity have different signs. So I am going to find the velocity at time 4, and I'm going to find the acceleration at time 4. And remember, acceleration is the derivative of velocity. So the velocity at time 4 is just our y1 at time 4, negative 11.4757. Acceleration is the derivative of velocity, and we want to know what the acceleration is at time 4, negative 22.2957. Okay. Since they have the same sign, the speed is increasing. So I'm going to say that. Speed is increasing at time 4 since v of 4 and a of 4 have the same signs. Okay, perfect. By the way, this was worth 2 points. Conclusion with reason. They quite likely split it up somehow, but they didn't show us how. So, conclusion with reason. The other way that I was talking about is this way. Speed, we have the equation for speed, and it's stored in for our y2. I'm going to turn off y1, and I don't need this 0 anymore. I'm going to go and look at the graph of the speed at time 4. Okay, so let's look at speed at time 4. Here's speed. Is it coming? Oh, I have it turned off. I'm going to have to turn on that graph, otherwise it's not going to show me a dang thing. Okay, there's the speed. There we go. And I'm not seeing everything that I need to see, so I'm going to go and see some more y values. I'm going to increase that to maybe 10. Maybe that's enough. I don't know. Let's see. That was enough. That was plenty. Well, I said that, but let's go a little bit higher. How about if we go to 20? In that case, I'm going to change my scale to nothing, so there's not all those hash marks. Okay. All right. At time 4, I'm going to trace to time 4. At time 4, is that graph increasing or decreasing? Well, it's increasing because its slope is positive. So another alternate way to answer this question would be that the speed is increasing at time equals 4 since the slope, that's exactly what we are doing to figure that out, the slope of the absolute value of v is positive. There. That would be another way to answer it, but this is probably the most direct way, I guess. Not really direct, but just it's the one that I'm sure you guys would use. Okay, so that was the first problem. The next one that we're going to do together is the one from 2022. So we will grab that. I'm going to grab my scoring guideline to see how this was scored. Way in the back. There we go. All right. This one was without a calculator. So we're going to need to do our calculations with no calculator here. Okay. Put my calculator away. Particle P moves along the x-axis so that for time greater than 0, its position is given by this. So here's the position of particle P. Particle Q moves along the y-axis so that for positive time, its velocity is given by this equation. So they're giving us the position of P and the velocity of Q. At time 1, the position of particle Q is 2. So they're giving us an initial position for particle Q. All right, part A. Find v sub p of t, the velocity of particle P at time t. Well, v sub p is the derivative of the position of P, which they gave us. So we're going to be taking the derivative of position. So the derivative of 6 is 0. The derivative of negative 4e to the negative t is positive for e to the negative t, because we multiply by the derivative of that negative t. Derivative of negative t is -1 times that -4 is a +4. This is the velocity of p at time t. That was worth 1 point for the answer. Part B. Find the acceleration of particle q at time t. Well, the acceleration of particle q at time t is the derivative of the velocity of particle q at time t. And that will be the derivative of 1 over t squared. Well, I can write 1 over t squared as t to the -2 so that I can use the power rule. So this will be -2 t to the -3. Okay, so that answers the first part. I'm sure that was worth a point. I'm just looking, and yes, it was. That was worth a point. Find all times when the speed of q is decreasing. Well, speed is decreasing when acceleration and velocity have different signs. So I need to examine when does acceleration, or what is the sign of acceleration. So acceleration is, I'm going to write this in a form that I can get some information out of it. I'm going to move that t to the denominator and give it a positive exponent. And they told us in this problem that t was always positive, right? T is always positive. Well, if t is always positive, then acceleration is always negative. Is less than 0 for all time greater than 0. The velocity of q is 1 over t squared. It is positive for all time greater than 0 or less than 0. Anything but equals to 0. So acceleration is negative, velocity is positive. The speed of particle q is decreasing always, since acceleration of q and the velocity of q have different signs. This was worth 3 points. 1 point for the acceleration of q in terms of t, the first thing we did. 1 point for considers the signs of a sub q of t and v sub q of t. And then 1 point for your answer with justification. Oh. Okay, hopefully that kept on going. My computer timed out. Alright. I need to plug this in so it's not going to turn off on me. Oh, anyway. Okay. Part C. Find y sub q of t, the position of particle q at time t. All right. Well, the position of q at time t will be the starting position plus the change in position. So the starting position occurred at time 1, so we'll need to keep that in mind. It occurred at time 1 and it is 2. So the starting position is 2, and we add to that the change in position. The starting position occurred at time 1. We want the ending position to be at any time t, and we have to put velocity in here, because the integral of velocity gives us change in position. So that would be the velocity of q of t. right? So it says to find, so we need to go ahead and find this. All right, so this will be 2 plus the integral 1 to t of my v sub q is 1 over t squared dt. So we need to integrate this. This is 1 over t squared. I am going to bring that to the top, bring it to the top, give it a negative exponent. And now we're going to use the power rule. Add 1 to your power, divide by your new power. Add 1 to a power is negative, to the power is negative 1. Divide by your new power, it's going to make it a negative 1 to t. And before I plug in, I'm going to change this to 1 over t. Okay, we put t in for t. Minus, now I put 1 in for t. Make sure you keep your signs right. So this would be the first safe stop spot. If you choose to reduce or simplify, you can, but be careful. So this would be a positive 1, so we'd have 3 minus 1 over t. No need to simplify though. All right, first point is for the integral. The integral here. 1.4 uses initial condition. That would be the 2, and then 1 point for the answer. Alrighty, one more part here. As time goes to infinity, which particle will be eventually farther from the origin? Give a reason for your answer. So as time goes to infinity, let's see where P is. Let's see where Q is. The position of P was given to us. So 6 minus 4e to the negative t. We want to know what is that limit as time goes to infinity. Well, again, I don't like to mess with anything when it still has a negative exponent, so I'm going to change that to be 4 over e to the t. It's easier to work with. Now we're going to let t go to infinity. As t goes to infinity, the denominator is going to infinity. 4 divided by something going to infinity is 0. So this piece right here is going to 0 because we have a super humongous denominator and only 4 on top. So this is 6. So P ends up, its long-term position will be 6. Let's do the same thing for Q. For Q, what is its long-term position? Well, its position we found right here. So its position is 3 minus 1 over t. As t goes to infinity, 1 over something going to infinity is going to 0 for the same reason we talked about just now. And this one will only be 3. So which will be further from the origin? P is farther from the origin. This was worth 2 points. 1 point for one correct limit and 1 point for your answer with reason. This is a really heavily tested topic, almost always on the AP exam. So make sure you do the number of problems I'm asking you to do in class.